Today I want to talk about quadratic functions and transformations. So, first of all, I want to re-go over it, or if you haven't seen this yet, I want to talk about what a quadratic function is, and then I want to do some examples. Okay? So a quadratic function is anything, any polynomial, so polynomial is basically a string of x's and numbers, variables and numbers, put together by plus and minus signs. So it's a polynomial with the highest degree of 2, okay? So quad, you'd think it means 4, but really in Latin, quadrus means squared, okay? It means square. And quart, like a quart of milk, means 4 in Latin, okay? So examples of what a quadratic would look like. Well, let's say x squared plus 5x plus 2, okay? It has a highest degree of x squared. Another one could be 3x squared plus 2, okay? Again, the highest degree of x squared, okay? There can be other x's in the problem, but the x to the highest power is always going to be an x to the second power, okay? So that is kind of what it looks like using algebra. Why does anyone care about these? Well, we care about these because they're super useful in modeling things, okay? A big one that you'll probably see in calc, it's used all over the place, is modeling projectile motion. So if you kick a ball, throw a brick off a building, anything like that, its position, okay, is determined by gravity, right? It's determined by gravity, and gravity is always accelerating. So what you can do is you can model this, the position of something that you throw in the air, something that you throw off a building, in terms of time, with a parabola, okay? If I wanted to know, say I throw a ball off the roof of a building, and I want to know what the position is of that ball at time 2 seconds, a parabola will give me that answer, okay? So it's very big with projectile motion. Another thing, it has a particular some particular properties that make it very nice to use as car headlights. So the headlights of your car are parabolic, okay, and that's related, okay. It's like a three-dimensional quadratic almost. And satellite dishes also require the same types of properties. So they also take this kind of shape that we're talking about, and that shape is the parabola. Okay? The parabola is the shape of the graph of a quadratic. Okay? So we're going to be talking about quadratics, and we're going to be graphing them, and they're all going to look like sort of like little smiley faces that we call parabolas. Okay, let's move on to our first example. So we're going to be dealing with a particular way to look at a quadratic, and that is called vertex form. Okay, it's called vertex form, and it looks like this. F of x is equal to some number a times x, which is your variable, your input, minus h is just some number, and that whole quantity squared, plus some number, and they label it k. Okay, so things to remember: a, h, and k, they're just numbers. Okay, they're just numbers. Nothing to be scared about. Like, I'll give you an example. G of x is equal to 5x x minus 2 squared minus 7, okay? Where a is 5, h is 2, and k is negative 7. All right? So a, h, and k, they just had to, to make it very generalized, they just had to put numbers in there, so they did. All right? These numbers, though, have some meaning. All right? The vertex, which is like, we'll say the point where the parabola, if you remember, these things are all going to look sort of like a smiley face or maybe a frowny face if it's flipped upside down. The vertex is this turning point, okay? So the vertex is, okay, so my parabola is going downward here. And then all of a sudden, after this turning point, after this vertex, it's starting to go upward, all right? So that's what the vertex is of a parabola. It also doubles as, actually, this is the minimum point on the parabola, right? This U shape here has a minimum point, and that minimum point is the vertex. In the same way, if our parabola is flipped upside down, the shape is flipped upside down, this vertex point, okay, the turning point, is going to be the maximum. So vertices can be maximums or minimums too. Okay? And we might get into that a little bit later. All right. So that's what h and k are. So if I gave you an example like f of x is equal to x minus 1 squared plus 3, okay, my vertex, okay, my turning point, my maximum or my minimum, is going to be 1, 3. So at the point 1, 3 on the graph, that is the turning point, or the vertex. All right. The next thing I want to go over is the axis of symmetry, okay? So if you remember, vertical lines have the equation x is equal to some number, and that just means a vertical line on your graph. All right? So in this case, the axis of symmetry, symmetry meaning on one side of the line, is going to be a mirror image of the other side. Okay, that's called the axis of symmetry, that line where you can fold over the parabola. Okay? And that's just at this point h. Okay, h is some number, and that's the number where you're going to draw your vertical line. Okay? Let's do a quick example. I want to make this video under 10 minutes, and we're already at the 8-minute point. So, I'm going to draw the most basic parabola using a chart, okay? Now, we could put a number in front of here, anything like that, but I want to just show you how to draw your most basic parabola using a chart. So we're going to plot it. And we're going to plot the graph of f of x is equal to x squared. All right? So I'll just pick some values for x, our input values. You're always going to pick your input values. So I'm going to pick one. I'll pick a couple. I'll pick 2, 0, and -2. Okay? So I'm picking here, right here, +2 and -2. Okay, let's see how this parabola, and maybe we'll branch out and make it a little bit bigger, but I think you'll get the idea. Okay, so to find our y value, we're just going to square this. So 2 squared is 4. 0 squared is 0. And -2 squared, well, you're squaring a -2 times -2 is a +4. Okay, so it's going to be 4. So our ordered pairs that we're going to graph are 2, 4, 0, 0, and -2, 4. Okay, let's graph those. One, 2. So at 2, it's 4. 1, 2, 3, 4. Okay, at -2, it is also positive 4. And our parabola looks something like this. Okay, so it's not perfect. Maybe I'd want you to draw a couple of more points, but this is what your basic parabolic shape looks like, okay? The axis of symmetry, well, if you look at this graph, if you write it out as, you know, maybe x minus 0 squared plus 0, right? They're just zeros in here to make it sort of look like this vertex form. You know, you get that your vertex, your midpoint, your low point is 0, 0. And you also get that your axis of symmetry is this line, x is equal to 0. Okay. I'll do another example in another video. I want to cut it off here because we're at the 10-minute mark. Thank you.